Hi everyone, this is my ecosystem report about the coral reef, and my name is Clara. So to get started, the primary producer I chose for the example was seagrass. They are organisms and they produce their own food through photosynthesis, and they're also categorized and called autotrophs because they do produce their own food. They are considered benthic because they are at the very bottom of the ocean. And some adaptations that they have is their roots. They help hold them in place in the sand so they don't like fall away or anything. And they also contain a lot of good nutrients and fibers to support their stems so they don't bend or break. For my primary consumer, I chose a smaller fish. These fish stay at the bottom of the ocean, considering them benthic as well. And they're also considered a heterotroph because it is an organism that requires nutrients from like an organic substance of a kind, like the seagrass, so it does feed off of that. These fish do stay at the bottom to feed off of it as well, which is one of their physical adaptations. And they're also kind of a dark blue color, and they kind of blend in with the reef and with the dark bottom as well. For the intermediate consumer, I chose a crab. These are also a heterotroph because it is an organism that relies on the of an organic substance. It is also considered benthic because it does hang out more towards the bottom of the ocean. And some of its physical adaptations, they have long claws being able to move faster around against the floor. And they also have multiple claws as well, just to be able to swim faster and protect themselves from other predators. For my top predator, I chose a tiger shark. They are a heterotroph. So again, they're relying on some other organism for their nutrients. And they're also pelagic because they kind of are more in the open ocean area, and they kind of stay towards the top and not so much the bottom, which we refer to as benthic. Some adaptations that they have striping on them that helps blend with them through the seafloor if they are down there. And their teeth are super narrow and are kind of more curved at the top to help swallow things that are bigger and things like that. And then for the decomposer, I chose a sea sponge. They are a heterotroph, so they're still getting nutrients from other things, even if those are dead organisms that they're feeding off of. They are also considered benthic because they do lay on the bottom of the ocean floor. And the thing about these is there's not a lot of things that are feeding off of them, except for those small fish and things that are at the bottom that feed off of the seagrass. And their bright colors help attract fish that protect them from other predators. So for my food web, I first started with the sun, because without the sun, the plants would not get any nutrients that they need. So with the sun, it shines on the seagrass, which starts photosynthesis and helps the seagrass produce what they need to survive. And then those small fish and things like that that are more on the bottom of the seafloor feed on the seagrass. And then from there, a primary consumer of those fish would be a crab, and things like that. And then those crabs get eaten by sharks, which are those top predators that kind of eats everything. And then off the side, with the sea sponge, it's feeding off of all those dead organisms that are probably left over from the shark, from the crab, anything, and they just feed off of that. And then the crab also feeds from the sponge as well, which kind of makes it more of a full circle / web. So for the abiotic factors, the first kind of main bullet point would be the temperature. This coral reef area kind of stays anywhere between 23 and 29 degrees Celsius. There are a lot of factors that kind of go in with the abiotic factors, and those factors are like water, temperature, sunlight, salt, waves, and these factors don't like make or break the ocean how it is, but it does kind of have like an influence on how things survive and things like that. And then for nutrients and water clarity, there is a lot of importance for the nutrients. All those things help the animals in the ocean survive and feed off of each other. Low nutrient side effects, it does happen. There's kind of always an imbalance of these things. But some low nutrient side effects is the decrease in population sizes. So when there's not enough nutrients in the ocean, a lot of species kind of start to die off because there's just simply not enough to go around and just slowly start to die off. But there's also times where there's too much nutrients, and it kind of, when there's too much, it kind of decreases the clarity of the water and makes it super cloudy and murky. But there's also, and with that being said, when it's super cloudy and murky, that means that algae is blooming, which is also not always the best thing as well. For salinity, that helps impact the coral growth, so that's always a good thing. You always want, and it also incorporates with ocean acidification as well, which kind of keeps the pH balance in full swing. All right, so for some chemical aspects of the coral reef, it increases the ocean acidity, and it reduces the availability of dissolved salts, ions, and that is needed from the coral. With the acidity, pretty much the more acidity, the more hydrogen atoms, which means less calcium carbonate, but more bicarbonate. For temperature, reefs grow up more in the water, and they grow better between 23 and 29 degrees Celsius. And the corals can also acclimate to different temperatures. When corals that are located warmer water are more resistant to heat, and identical coral that lives cooler in the water. For geological aspects, it impacts the coral reef's ecosystem. Cooler water temperatures elevate nutrients and reduces pH levels. In coral, granite makes up much of the beach sediments as well. Some physical aspects of the ocean is an increase of ocean temps. And that's honestly one of the greatest threats of the ocean, is the increasing of the water temperature. And the increase of those temps is typically caused by a warmer atmosphere. And also increases the level of carbon dioxide too, which is another factor. And as those atmospheric temps rise, so does the seawater. Low tide is another kind of part of the physical thing. Low tide forms upper limits of the ecosystem. And then the high tide gives the deeper, or it hides, the high tide gives deeper water predators more access, so they're kind of able to get up higher and closer to shore since the tide is a lot higher. Large waves also affect the corals, and also kind of the coral also kind of adapts to survive those big waves. So that was my presentation. A couple other things just to talk about. And again, I think that is very important.